In most ways, the brain is symmetrical. So most functions that come from each of the structures exist in each hemisphere. This means if you have damage to one side of the brain, the other side can still help in those particular functions. But there are a couple of ways in which the two sides are not symmetrical. These are in processing certain kinds of information. The left hemisphere specializes in verbal activity, so things like language, math, reading, writing. Okay? Now the right side specializes in nonverbal activity, so things like drawing, expressing emotion, reading emotion in others. Subtle inferences, that's an interesting one. And even multitasking, for instance. Now, if I asked you to visualize rearranging the furniture in your own room at home, you would mostly be using your right brain because that is a nonverbal task. When I was an undergraduate, I came up with this cool way to help remember the difference. Here we go. The left brain reads the words. The right brain reads between the lines. So the hemispheres are mostly symmetrical. However, there are a few important asymmetries. The left side of the brain has two special areas for language. Broca's area for language comprehension and Wernicke's area, spelled with a W, for language production. So we've got language comprehension, Broca's, and language production, Wernicke's. Now, when then Representative Gabriel Gifford was shot, there was special concern about this being in the left lobe because it is the only side with language. When she came out of her coma, they finally found that it had damaged her Wernicke's area, but not Broca's. So she could still comprehend language just as well as before, but she has great difficulty producing language. Now there's one more cool specialty area, this time mostly in the right hemisphere, and it is called the fusiform face area. And it makes it possible for us to recognize faces. Okay, I want to do a demo here to demonstrate left and right brain interference. This is called the STRIP task, but you don't need to remember that, what it's called in particular, if you remember this demo. So here we go. When I switch to the next slide, you will see two columns of words. You're going to read them, but you're not going to read the words. You're going to read the color of each word. Okay, out loud. Don't turn your mics on, but do read them out loud as fast as you can. First the left column, then the right. Okay, it's really just one column. I had to split it up to fit on the page. And remember, say the color, not the word. Finally, you must go as fast as you can, but you also must be accurate. If you make a mistake, you must stop and answer it correctly before going on. Ready and go. Okay, most people are done by now, and we need to do this once more. So as quickly but accurately as you can, here we go. Okay, we don't need to finish this if you haven't for you to get the point. Most students take much longer to read this list because your left brain interferes, right? You were asked to do a right brain task, but your left brain messes with you on the second run because it gives you a different color. So this is a really great demo of how each hemisphere has a different specialty. Now, another important thing about the word specialize is that it is not exclusive. If we were to have you rearrange your furniture visually while having your brain scanned, the right side would light up the most by far, but we would still see a small amount of scattered activity in the left hemisphere. And we will be expanding on this a little further into this lecture.